index notation. In this session, we will talk about why do we need index notation and how do we write it. Okay. Let's start with something that we are more familiar with, that is the multiplication. What is actually multiplication? Let's look at this expression. 5 plus 5 plus 5 plus 5 equals to 20. So you're essentially adding 4 of the 5 together, and that equals to 20. So is there a shorter way to write 4 of the 5s added together? Yes, there is. That is 5 times 4. So mathematicians won't bother to write such a long thing just to add it to 20. So instead, it is a quicker way to write in multiplication. So that's how we define multiplication, right? It's 4 of the 5s adding together. That's 5 times 4. Yeah? So in this sense, multiple addition of the same number is equivalent to multiplication. Or you can say it the other way. Multiplication is essentially multiple addition of the same number. Okay? Here, 4 is the times that you want to add 5 together. Okay? Then, what if we need to write multiple multiplication of the same number? For example, here, 2 times 2 times 2 times 2. So you have 4 of the 2 multiplied together, and that equals to 16, right? Can we have a shorter way to write it, or a faster and more intuitive way to write it? Well, mathematicians came up with a faster and more intuitive way to write multiple multiplication of the same number, and that is called the index notation. Well, some people say it's just a lazy way to write it. It's true, because it will be shorter and it represents the same value. For example, the 4 of the 2 multiplied together, we can actually write the number that we want to multiply, that is 2, and then we put the times we actually want to multiply it together in the upper right corner, and we write it in a smaller fashion as a superscript. Okay, so 2 is the number we want to multiply, and 4 here in the upper right corner in a smaller way that was written, it means the times that we actually want to multiply to. Okay? And these two expressions equals to the same value. Okay? So this 2 with a superscript 4 is what we call the index notation. Let's see another example. 6 and 5. Okay? Here 6 is the base. Okay? And 5 is the power or exponent. What does it mean, power exponent? Basically, the upper right-hand corner 5 is the time we want to multiply the base 6. Okay? So the smaller number in the upper right-hand corner is called the power or the exponent, and it means this is how many times we want to multiply the base number. And the normally formally written base number is the number we actually want to multiply. Okay? So this expression reads 6 to the power of 5 essentially equals to you multiply 6 5 times. Okay? And then they should equal to the same value. Okay? Let's recap. When we write a base number and a superscript with a smaller number there on the upper right hand corner, it reads the base number, in this case 6, to the power of the exponent or the index or the power, which is power of 5. So 6 to the power of 5, that is equivalent to you multiply 6 by 5 times. Yeah? And that equals to 7,776. Okay? Now let's try an example. How do we expand these expressions? Well, with index notation, if you can read it correctly, you can expand it correctly. How do you read this? A with a superscript 3. It's essentially base A to the power of 3. So the base number is A, and the exponent is 3, so it expands to a times a times a. Yeah? For b, it's xy to the power 4. So actually xy bracket to the power 4. That means your base number is x times y. Here, the dot is what I use to emphasize that xy means x times y. Okay, so the whole product of x times y is our base here. And then the exponent is 4. So we need to multiply the product of xy 4 times. Okay, c is 2 times a to the power of 3 and times b to the power of 2. So that means both a and b are our base here, but a is raised to the power of 3 and b is raised to the power of 2. And therefore, when they are multiplied together, they becomes 2 times a times a times a times b times b. If we swap the a and b's, the letters, for numbers, it works in similar ways. We just need to be very careful with what the base number is. For example, here, 5 is your base number, so you need to multiply 5 3 times. And here, your base number is -2. So every time you multiply, you're going to multiply -2 5 times. Okay? Here, in C, your base number is a fraction. That's 2 on 5. So when you expand it, you're going to multiply 2 on 5 3 times. And therefore, they expand in that way. Alright?